All right. Good morning, everybody. Welcome to today's class. So we're going to continue from where we stopped, the little minutes that we have. So far, so good. As far as this course is concerned, we've been looking at um, the climate. The first class we discussed on climate, the components of the climate system, and every other thing. The second class we discussed the greenhouse effect, the causes of greenhouse effect, the importance of greenhouse effect, and of course how we can actually solve the problem. Then last week we looked at global warming, the causes of global warming, its effects, and of course the solutions to global warming. So that's how far we have gone as far as this course is concerned. So today we're looking at climate change. Climate change is like a prerequisite to what we've been discussing since, and by the end of today's class, we'll be able to understand what climate change is, and we'll look at the causes. Okay, so look at climate change, definition of climate change, the causes of climate change, which is characterized into two, both the natural causes and the human causes. Then, of course, effects of climate change. Okay, and what is the solution to climate change? All right. Then by next week we'll look at spillage, and we'll continue from there. So basically, that's what we're going to look at today. So when we define climate change, when we talk about climate change, we're talking about the changes that occur in our weather patterns or the climate pattern, the periodic modification of Earth's climate, okay, brought about as a result of changes in the atmosphere. Okay, so those modifications you find in the Earth's climate, okay, because of certain changes that occur in the atmosphere, and also the interaction between the atmosphere and the various other geologic, chemical, biological, and geographic factors within the Earth system. So basically, that's what climate change is. Okay, when you have a modification, normally when the climate was supposed to be a particular thing, and then you have a variation or modification in such climate because of the changes that occurred in the atmosphere or the interaction that occurred between the atmosphere and other factors you find in the environment, which can either be atmospheric, geologic, chemical, biological, and geographical factors. These are various environmental factors that also affect climate. So when you have such modification, that is what referred to as climate change. And of course, you know that when we talk about those changes in the atmosphere, it can be due to the effect of a greenhouse effect, increase in temperature, ozone layer depletion. We've discussed all those things when we talked about greenhouse effect and global warming. So all these interactions, all these changes that occur in the atmosphere, excess emission of greenhouse gases, all these things can bring about modification of the climate, thereby leading to climate change. Others can be natural, which are the geological, chemical, biological, and geographical factors. So all these things that occur in the atmosphere, in the earth system, that changes the climate of a particular place is what referred to as climate change. Okay, so basically now the atmosphere, like we know, is a dynamic fluid, and it is continuous in motion. It's a dynamic fluid. It flows. That's why when you look at the atmosphere, you see water molecules and other things moving, gases and the rest of them. They are dynamic in nature, and that's why they can move. Now, the physical properties now and the direction of this motion, okay, are also influenced by a variety of factors, which can also include solar radiation. Then another thing that can also affect this movement, the geographical position of the continents, ocean currents, the location and orientation of mountain ranges, atmospheric chemistry, and probably vegetation growing on the land surface. Now, all this brings about, what I'm trying to tell you is, all these things I just mentioned are the things that brings about changes within the climate. Okay, so at one point or the other, these things definitely will cause climate change. Okay, so therefore, climate now, which results from the physical properties and motion of the atmosphere, varies at every conceivable time scale. So even as the changes occur in a particular area, it may not be the same in another area. Okay, because it's dependent on the reaction, on um, the um, the relationship or the interaction, okay, of these environmental factors and these changes that occur in the atmosphere in a particular environment. Okay, so basically that is what climate change is all about. All right, so changes which is attributed directly or indirectly to human activities that alters the composition of the global atmosphere, and which is in addition to natural climate variability observed over comparative time period, is also referred to as climate change. So these are different definitions of the climate change. But basically, once we talk about climate change, we're talking about those changes that occur within the climate system as a result of the direct and the indirect activities, okay, that takes place within the Earth system that alters the composition of the global atmosphere. That's basically what climate change is all about. So let's quickly look at the causes of climate change. What are the causes of climate change? The first one we have there now, so we're going to look at the causes of climate change under two broad topics. We have the natural causes and we have the anthropogenic causes. Natural causes beyond human factors, beyond human cause. Sometimes even if activities of human can also trigger these natural occurrences. But when we talk about natural occurrences, it just happen on its own. Man has nothing to do with it. Why the anthropogenic causes is actually the human factor, the ones caused by human. So we're going to be starting with the natural causes of climate change. Now, the first we have on that list is volcanic eruption. Of course, we know what volcanic eruption is. The eruption of volcanoes, okay, beneath the earth crust when the pressure blows. The eruption of molten magma, okay, when the pressure beneath the earth crust increases, okay, to the extent that it begins to exert pressure within itself and beneath the earth crust. That is what volcanic eruption is. So these molten magma are being shot up from beneath the earth crust, thereby, you know, cooling down to form the rocks and the volcanoes that we have. So that's basically what volcanic eruption is. The eruption of molten magmas due to the high, the very high pressure that's been built beneath the earth crust. Okay, so that is volcanic eruption. Now the question is, how does this volcanic eruption cause climate change? How does volcanic eruption cause climate change? Now, one thing I need us to understand is this: that overall, okay, generally, volcanoes release less than 2% of the equivalent amount of carbon dioxide released by human activities. That's one thing I want us to understand about volcanoes, of volcanic eruption, that volcanoes release less than 2% of the equivalent amount of carbon dioxide released by human activities. So you can agree with me that that's quite small. But what happens is that, and research have also shown that it takes about or this volcanic eruption occurs about once every 20 years. Okay, so once in every 20 years we must have a volcanic eruption. Okay, now because it takes a whole long time before volcanic eruption can occur, you will agree with me that a lot of gases must have been built up beneath the earth crust. And as these molten magmas are being erupted, what happens? It also throws out a tremendous amount of particles and other gases. And when they erupt now, these particles and these gases are being emitted into the atmosphere. So what happens is that when these gases and these particles get to the atmosphere, it will definitely effectively shield us enough from the sun, okay, that will lead to a period of global cooling, okay. So when these gases get into the atmosphere, they shield the heat from the sun, they shield the sun from cooling, from getting to the earth crust, okay. So what happens is that when they are being shielded within the climate, within the atmosphere, now this heat begins to build up in the atmosphere, and before you know it, there will be a disruption in the climate. There will be a change in climate because normally this heat are supposed to drop, okay, in the earth crust, but because they're being shielded, these gases now goes and shield this heat from coming. This heat builds so much in the atmosphere, leading to, climate change. So that's basically how volcanic eruption leads or causes climate change. So you see, talking about when I define climate change, I talked about those variations that occur in the climate system due to the interaction, okay, of the climate with other particles and also other factors like the geologic. This volcanic eruption is part of geologic factor that we're talking about that leads to climate change, okay. So that's basically how volcanic eruption causes climate change, okay. So these particles and these gases typically dissipate after about 2 years, but the effect is nearly global. So it takes about 2 years for these gases and these particles to cause this effect on the climate. And it takes about 2 years to do that. And the effect is usually global. So that's how volcanic eruption actually causes climate change. Okay. Number two is ocean current. Ocean current. Okay. Now, how does the ocean affect climate and weather on land? You can agree with me that the ocean influences weather and climate by storing solar radiation, distributing heat and moisture around the globe, and driving weather system. We know this about the ocean because it takes a whole lot of solar radiation, distributes this heat once it receives it, and also moisture around the globe and driving the weather system. But one way that the world's ocean affects weather and climate is by playing an important role in keeping our planet warm. We know that because they trap in a lot of radiation from the sun and then they distribute it. Okay. Now the majority of this radiation from the sun is absorbed by the ocean. Okay. Now, particularly like in the tropic waters, the tropic region, especially the tropic regions close to the equator, okay, where the ocean acts like a massive heat retaining solar panel. In the tropics, like Africa, we know very well that ocean plays a very big role in getting a lot of or retaining a lot of heat, solar radiation from the sun. So they act as a solar panel. Now, land areas also absorb some sunlight, and the atmosphere helps to retain heat that would otherwise quickly radiate into the space after the sunset. So now what happens is that the ocean doesn't just store this solar radiation, it also helps to distribute this heat around the globe, just like I've said. Now, when these water molecules are heated, they exchange freely with the air in a process called evaporation. We talked about that when we were talking about water cycle in the first class. I told you what happens at the hydrosphere. Okay, evapotranspiration. Now these water molecules get back to the atmosphere through evaporation and transpiration. So when the water molecules get heated, what happens is that this free air, this vapor, okay, are being exchanged with the atmosphere in a process called evaporation. Okay, so ocean water is constantly evaporating heat and vapor, okay, increasing the temperature and humidity of the surrounding air, okay, to form rain and storms that are then carried by trade winds. Now, in fact, almost all rain that falls on land starts off in the ocean. So the tropics are particularly rainy because of this heat absorption. Okay, so ocean evaporation is usually highest in that area because of our intensity of heat. Okay, Now, outside the Earth equatorial areas, now what happens is that the weather patterns are driven largely by these ocean currents. Okay, now um, this current now that we're talking about, the ocean current that we're talking about now, are movements of ocean water in a continuous flow, which was actually created largely by surface winds, but also partly by temperature and salinity gradients. Okay, so these current systems typically flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So when this now occurs, it transports a lot of warm water and precipitation from the equator towards the pole. Okay, so that's how it affects the global climate. Okay, so ocean current, the Earth, the northern hemisphere. Okay, during Earth rotation and tides. Okay, it helps to regulate the global climate. But when this becomes too much, it becomes counterproductive. Okay, so that's how ocean currents actually affect causes global warming. Okay, so without this current in the ocean, regional temperatures will be more extreme, super hot at the. Okay, so that's how ocean current actually cause climate. I know many of us will be wondering, what am I saying? It's not making much sense because I'm speaking too many languages. But what I'm trying to explain in effect is that number one, the ocean helps, okay, in regulating water between the atmosphere and the earth crust through evaporation. Okay, now when this water gets into the atmosphere, when this vapor gets to the atmosphere, it cools down and then falls back as water. We understand that. Now, apart from that particular function for evaporation, I said it helps to conduct or to trap solar radiations from the sun, thereby heating up the ocean. Now, when the ocean becomes so heated, because there's what we call ocean currents, okay, that helps to transport or move this ocean current is responsible for the cooling and the heating or the warming up of the earth crust. So now remember that already the radiation that has been trapped from the sun, if it becomes so high and they are being emitted from the oceans due to the ocean current, this can increase the temperature of the atmosphere. Because when evaporation is taking place, not only is the vapor going into the atmosphere, we also have hot air, okay, that's also being moved into the earth crust. So it also contributes in the increment of temperature, which can also affect the climate of that. So that's how ocean current causes climate change. Okay. Then for the solar variation, how does solar variation cause lead to climate change? Now, radiation from the sun makes Earth a habitable planet. So without radiation, I don't think we'll be able to all survive because plants depends on this light from the sun to produce food, and then we on our own part depends on this plant for feeding. So when there's now fluctuations in the solar output, okay, are therefore likely to affect the climate on Earth. So when there's a fluctuation, okay, in the amount of radiation or radiated heat being released from the sun, this can effectively, okay, affect the climate change. Now, what you need to understand is that we need to now establish between the output of the sun, okay, and also the variation that takes place within the earth crust. That's how we'll be able to measure to know how this solar variation actually affect or contribute to climate change. Okay, so basically what I'm trying to say in effect is that as much as this sun are being radiated from the this heat are being radiated from the sun, which gets to the earth crust, if there's a variation or fluctuation within this radiation, it can actually lead to climate change. Okay, that is how solar variation can also contribute to climate change. Okay, so when there's a fluctuation in the amount of heat being radiated from the sun that can cause solar climate change. So those are some natural, okay, causes of climate change. Now there have been other articles too, okay, that have listed other causes of climate change. There have been several articles, so it's not just these three things that we talked about. Okay, they have also caused. We have ice sheets and the sea ice, terrestrial vegetations and ocean temperatures have also been um, noticed to also cause variation in the climate. Okay, then we have periodic changes that occurs in the Earth's orbit. Remember, we said the Earth is always revolving and rotating. So when there's a periodic changes in the Earth's orbit, and probably let's say for example the axial tilt with respect to the sun, that can increase the temperature by 1,000, which can also lead to um, climatic or climate change. Then we have tectonic movements, okay, that is changes in the shape, size, position, and elevation of the continental mass, okay, and also the bathymetry of the oceans. All these things can also contribute to climate change, okay. So those are other things, other natural causes that have also been pointed out to be the major, to be causes of climate change. But the major ones are these ones that we discussed: volcanic eruption, ocean current, and solar variation, okay, heat variation from the sun. Now let's look at the human causes, which is the anthropogenic or the man-made causes. We have greenhouse gases. I don't need to overemphasize on this because last 2 weeks we treated so much about greenhouse gases, how they have been emitted into the atmosphere. We gave examples of some greenhouse gases, the halons, the inert gases. One of the major greenhouse gas that has been emitted is the chlorofluorocarbon, which after photodissociation has taken place within the earth crust, splits carbon, chlorine, and fluorine differently. And this naturally have a very big effect as far as the climate change is concerned. So the emission of these greenhouse gases, when they become so much, when they get accumulated, too much accumulated in the earth, in the atmosphere, can actually lead to variation or changes in the climate. Okay, so that's how greenhouse gases also do that. Deforestation. Now, when you cut down too many trees, what do you think is going to be the effect? Remember that these plants or these trees you're seeing, they help number one to shield part of the heat that is being released from the earth. So they absorb them because, like we said, the green pigments of the plant needs these plants, these heat from the sun to manufacture their food. So you see that the plant helps to absorb some of these heat that is coming from the atmosphere. Number two is that the trees also help to distribute wind, thereby bringing a cooling effect. Okay, especially when there's a rise in the heat in the atmospheric temperature. Now, but what happens now when all these trees are cut down, completely cut down? What is going to happen? There will be a rise, an increase in the temperature of the earth crust, okay, due to the radiation coming from the sun. And this over time can also cause a serious climatic change, okay, or climate change as we have it. So that's how deforestation contributes to climate change. Okay, then the next one that we have there is the coal mining. Coal mining, okay, is also another cause of climate change. Now, how does coal mining affect it? Now, understand one thing, that during when you're mining coal, a lot of greenhouse gases are being emitted. Okay, so the process of mining actually contributes. In fact, research has shown that during coal mining, 21% of the carbon dioxide that is being emitted into the atmosphere comes from during coal mining. Okay, so you see, and you remember that we pointed carbon dioxide as one of the major greenhouse gases, okay, in the atmosphere. Okay, so coal mining can actually help to emit much of these greenhouse gases into the atmosphere. And then what they do is that when they get there, they shield the atmosphere, thereby increasing the temperature of the atmosphere, which can also lead to climate change. Okay, so during coal mining or during processing of this mining, a lot of things are being produced. Some of these waste products include the fly ash, the bottom ash, and the flue gas desulfurization sludge. And all these things I said, especially this flue gas desulfurization sludge, contains mercury. This is heavy hydrocarbons, mercury, uranium, thorium, arsenic, and other heavy metals. Okay, now some of these things get into the atmosphere and then causes a lot of global climate change. How much more the health effect of this coal mine or burning coal? It also have a great effect on human health. So that's how coal mining also contributes to um, climate change. All right. Then the next is industrial processes. Of course, industrial processes, fossil fuel, gas emission. When you emit all those things into the atmosphere, it also contributes in climate change. Okay. These industrial processes are in form of industrial pollution. Okay. So when gases are being directly from companies are directly being fled into the atmosphere, it will soon, after over time, it gets accumulated, and then it can also lead to climate change. Okay, just like greenhouse gases, some of these byproducts of an industrial process is also produces these greenhouse gases, which when they also accumulate in the atmosphere can cause a serious climate change. So you see how man-made practices, okay, also causes climate change. Okay. Now the next one that we're going to be looking at as one of the anthropogenic causes of climate change is agriculture. Okay. Agriculture also contributes to climate change, and I'm going to explain how agriculture contributes to climate change. Okay, now it's almost close to the deforestation that we talked about. When you open up a piece of land, okay, for agriculture, especially for those people that practice commercial farming, okay, a very big vast of land is being opened. Exactly what happened to deforestation also does that. So you discover that sometimes the climate, agriculture can also affect climate changes. Okay, now climate change is affecting the distribution of plants, invasive species, pests and diseases, vectors, and geographical range and incidence of many human, animal, and plant diseases. Okay, so agriculture also plays a very big role in contributing to climate change by tilling, deforestation of all these plants and animals that would have been able to absorb some of these heat and also distribute wind to bring a cooling effect. So basically, that's how um, agriculture contributes to climate change. Okay, so those are the anthropogenic and natural causes of climate change as we have it in the earth. Now let's look at these charts. This pie chart that we have, um, it shows the amount of greenhouse gases we have in the atmosphere. You can see that carbon dioxide takes the highest, about 64%. Carbon dioxide takes 64%, chlorofluorocarbons take 11%, nitrous oxide takes 6%, and then we have the methane taking 19%. All these things are gases that are responsible for climate change because when they get accumulated in the atmosphere and shields the solar radiation, it leads to a serious climate change. So carbon dioxide takes the highest part or highest share of it, followed by chlorofluorocarbons, and then we have the methane. After carbon dioxide, we have the methane, followed by chlorofluorocarbon, and of course the nitrous oxide. We talk about green effect, where these greenhouse gases, okay, get into the atmosphere. It brings about what we call greenhouse effect, okay, making sure that this temperature or this heat are being circulated, you know, throughout the season, okay. That's one of the major importance of greenhouse effect, which we explained last week. Okay, but when it gets too much, it starts having negative impact as far as the thing is concerned, the climate is concerned. So this deforestation, like I've explained, how it causes how it contributes to climate change. Okay, now this coal mining, so you could see what is being emitted during that coal mining. I talked about those heavy metals due to deforestation of this coal. They are all being emitted into the atmosphere. The burning of fossil fuels has to do with industrial processes. I just explained. You can see the amount of gases being fled into the atmosphere due to industrial process. Okay, okay. You can also see this CO2, how they are being channeled into the atmosphere. So those are some of the causes, and of course, the agriculture. They also talked about global warming and the humans. Fossil fuel contributes about 49%. Industrial processes takes 24%, deforestation takes 14%, and then agriculture takes 13%. Fossil fuel 49%, industrial process 24%, deforestation 14%, and of course agriculture 13%. Threat of climate change is not the same thing as we have for the global warming. Okay, when you have global warming, we discussed the effect of global warming last week. So the effects of climate change are the same as that of global warming. Rise in sea level because there's increase in the temperature of the atmosphere. Okay, the iceberg, the glaciers, like we discussed, begins to melt, thereby increasing the water level. Okay, so there's rise in sea level as one of the effects. They have heavy rainfall across the globe, heavy rainfall due to excess evapotranspiration. And excess evapotranspiration is as a result of the increase in temperature, okay, of the earth crust. So we have heavy rainfall across the globe. Then extreme droughts, okay, is also another, especially during the dry season. When the temperature is too high, it dries up, plants can no longer survive because of excess temperature, thereby causing drought during the dry season. And that can also lead to impoverishment, so, reduction in food supply, plants no longer do well, and the rest of them. Then decline in crop productivity, okay, because temperature is too much for the plants to survive in such area. Then ecosystems begins to change. You see changes in ecosystem. Okay, we no longer have seasons anymore. Okay, because of all these things. Then hurricane becomes on the rise. There's rise in temperature. Carbon dioxide acidified water. Because remember, when these greenhouse gases are into the atmosphere, I talked about the acid rainfall. It doesn't just fall as ordinary water; it falls an acid rain, thereby acidifying the seawater when they get there. Okay, so those are the effects of climate change. And of course, you and I have a very big role to play as far as preventing climate change is concerned. Okay, how do we prevent climate change or how do we improve on climate change? Simply those things we discussed on how to reduce global warming and greenhouse gases can also be used. Okay, reduce emission into the atmosphere. Okay, we should have a plan. Our industry should have plans on how to recycle, reuse, recover, and reduce emissions of these fossil fuels and um, greenhouse gases to the atmosphere. Okay, there should be legislations enacted, okay, to also deal with these things. Legislations on air quality, on water quality, on environmental quality, and the rest of them. Then there should also be a continuous statistics taking, okay, about the variations that occur in the climate, so that when it's becoming too worse, we'll know what to do about it. So based on the results we got about carbon footprint, we discussed different ways to reduce it without losing quality of life. Okay, so we have a lot of things to play as far as the country is concerned. Okay, because when we protect our climate and our weather, our climate system, flood will reduce, drought will reduce, those areas becoming too hot. So those are the things you need to do. So you can consult your note, because my time is up. You can consult your note on how we can solutions to global warming. We can actually do that. Once we're able to find solutions to this global warming, climatic change will also work. That. All right. So thank you very much for participating in today's class. And then when we come next week, we'll look at spillage. Okay, look at spillage, look at the types of spills and everything associated with spillage. Thank you so much and have a lovely day.